Good day, students. Today I'm going to solve some examples on the theorems that I've taught you. We have looked at the fact that the angle subtended at the center is twice the angle subtended at the remaining part of the segment. We have also looked at the theorem angles in the same segment are equal, and then we have looked at the theorem the angle in a semicircle is 90 degrees. We have also looked at the theorem that the distance between the center of the circle, the line that comes from the center of the circle to meet a chord, all right, is at right angle degrees, and it bisects that chord. So we have looked at four, theorems that are related to circles. So I felt I should give you two more examples today to explain, what I've been looking at. So look at this question. We have circle PQRST, and then we are asked to find X and Y. We are asked to find X and Y. Solution. Okay, when you have a question like this, you have to think of as many theorems as possible that can be used to solve the question. Okay, all right. So if you look at this is X and this is Y. Then I want to show you something. Now, if you start, now look at where my two fingers are. If you start from here to come here, are you with me? Then you go here, you start from here to come here. You observe that this place and this place, they all started from here. So they are angles in the same segments. All right, they are angles in the same segment. Let me look at it again. This angle, right, and this angle. So y equals to 40 degrees. It's simple. All right, y, angles in the same segment. Are you with me? Then let's look at the next one. Look at this. This, okay, and that. Look at that. This and that. So x and 98 degrees. X and 98 degrees. They are angles in the same segment. Okay, so we also say x equals to 98 degrees. All right, angles in the same segment. That's all. All right, so I'm just trying to show you that a question may look complex, but if you understand the theorems that surround the question, you're going to solve the question easily. So let's look at the second question for today. All right, the question here says find X, and please take notes when you see something like this. This is the center O. Now I usually tell students that immediately you see a line pass through the center like this, that means that this is a diameter, so that means this is a semicircle. And most of the time such questions we have to use that theorem. Angle in a semicircle is 90 degrees, so we have to use it most of the times. Okay, so pay attention. So that means that if this is the semicircle, that means this place is 90 degrees. Angle in a semicircle. So now this is not labeled, so we can label it ourselves to make it easier. A, B, C, D. Okay, so we can say B, C, D. Solution. BCD, angle BCD is 90 degrees. Y, angle in a semicircle, is what? Is 90 degrees. Is that clear? So now we are almost there. Then we also realize that if I pick this, are you with me? And it goes like this is X. And I pick this and I go like this is also X, because angle in the same segment. All right. So that means if this is X, this is X too. Pay attention. If this is X, this is X here. So we can say angle BDC. That means angle BDC is equals to X. Y, angle in the same segment. All right, angle in the same segment. Okay, angle in the same segment. Is that clear? All right. So the next, we've not gotten X. We are getting there gradually. We realize that this is a triangle. So, and we seem to have all the parts of the triangle. Okay, we have x, we have 48, and we have 90 degrees. We have, this is 48. We have x, we have 48, we have 90 degrees. So we know that sum of angles in a triangle is what? Is 180. So we say x plus 90 plus 48 equals to what? 180 degrees. Why? Angles in a triangle. Is that clear? Angles in the triangle. So we have x plus 138 equals to 180. Okay, so we have x equals to 180 minus 138, x equals to 42 degrees. So that's that about that. The truth is, to really understand this topic, you have to take as many examples as possible. You need to practice as many as possible for you to really understand, how to analyze these topics. All right, so before I round off today, I'm going to explain something very, very, very important, and that is what we call cyclic quadrilateral. Cyclic quadrilaterals. What are cyclic quadrilaterals? All right, now these are four-sided shapes, all right, in which the four vertices, all right, touch different parts of is the circumference of the circle. These are four-sided shapes. Cyclic quadrilaterals are four-sided shapes in which the four vertices, all right, touch different parts of the circumference of the circle. Let me give you a very good example. Okay, this is a good example of a cyclic quadrilateral. This is a circle, and we have something like this: 1, 2, 3, 4. All right, this is a vertex. All right, this is a vertex. This is a vertex. This is a vertex. This is an example. Let me give you a shape that is not a cyclic quadrilateral. The shape is not a cyclic quadrilateral. Let me give you an example. Look at something like this. So we say ABCD is a cyclic quadrilateral. All right, is a cyclic quadrilateral. Let me give you an example that is not. All right, if you have something like this, all right, this is a cyclic quadrilateral, 1, 2, 3, 4, but it's not cyclic because the four vertices do not. All right, this is not a cyclic quadrilateral. Is that clear? All right, so why am I defining a cyclic quadrilateral? Why? There is a theorem attached to cyclic quadrilateral. That will be theorem 5 now. Remember, we have started from number 1, theorem 5. Okay, theorem 5, which says that opposite angles in a cyclic quadrilateral add up to 180 degrees. That is, they are supplementary. They add up to 180 degrees. Something like this. If you have something like this, this. All right. This angle, let's say this is x, this is y, A, this is B. X plus y is 180 degrees. A plus B is 180 degrees. All right. So next class, we are going to take an example to that regard. All right. In that regard, sorry, we're going to take an example in that regard, about cyclic quadrilateral. Okay, so then I'm still going to send the classwork to you on circles later in the week. Have a beautiful day ahead. Thank you.